Good morning. My name's Ed Lewis. I'm from ICANN. I'm here to talk about the KSK rollover. Or actually, I'll let Jeff do it because everybody else is coming down the road with who's going to talk about it. Let's just kick a can down the road. But no, I'm going to describe the KSK rollover project, where we are, and give you some information that might be helpful to those who are actually having to do the work involved responding to this KSK rollover. For those of you who are not that familiar with DNS Sec, DNS Sec is a way of extending the DNS to be more secure. And we do that by adding digital signatures. And this means we have those that sign data and those that validate the data. This is all about the validation side of DNS Sec. Those who are taking data that comes into them and making sure that the data is secure will be impacted by the fact that the KSK is going to be changed. To put this in a graphical form, the KSK is the top key in this hierarchy. I won't get into too much detail about the hierarchy or the way this is all put together, but the KSK that we're rolling is the top of just about every operational chain of keys that will lead to data being secure. In the talk, there's a reference to ZSK. Don't worry too much about this for our purposes. KSK and ZSK are different ways the same kind of key is used, key signing key and a zone signing key. Now, this rollover is an interesting event to us for a couple of reasons. One is that there was a long time when there were no keys. We added a key. That isn't a big deal to add something new because most people don't even notice that. They don't notice that you've added security in a way that's backwards compatible. The problem has been that we have one key now and we're going to change it for the first time. Many developers have taken that one key that we've been using and embedded it in software in places. Changing to a new key now, that's the problem, because that old key goes away, there are problems. The second thing about this project, which I don't reflect here, is that there's absolutely no way in the world to tell who is actually using the current KSK. The DNS is intentionally distributed. People do what they want with this protocol. We have no way, we who are running the KSK don't know who's using it on the outside, and you really don't want us to know who they are. This is all about independence. Milestones for this project right now, we created the key back in October of 2016. We've gone through a bunch of steps at this point. As you see, I've crossed out some of the deadlines there that we've passed. We're down to the next one as being October 11th, the date you've heard, no doubt, in the previous part of this session, if you were here. On October 11th, we are going to change the signature, the key that's generating the signature. This may cause disruption for folks who haven't followed along with the key change. Later on, we'll clean up the key and go on to the next But right now, October 11th is the next big event, which is the actual flip from the old key to the new key in production. For those people may come across the new key in different ways. Just so that you can identify which key it is, will help you identify it. It has a number, 20326, and there are other formats on this slide and the next slide. I'm not going to read this slide. It's cryptographic, it's base 64, it's not meant for human consumption. I hope that you can download these slides and have them for reference if you need this information, but this is what the new key is supposed to look like if you trust what you see on the screen. Now, the current state of the DNS Sec system is it's running fine. We're changing the key under good conditions. We're doing it for hygiene. We want to make sure that we can do a key in an emergency if we have to, but things are okay. And so because of that, we're using something called automated updates. ICANN is following this protocol, which we introduced the new key by using the old key to help you trust it. We've been pushing this for quite a long time, saying if you want to participate in this, the easiest way is to turn this on and go forward. Unfortunately, right now, it's almost too late. We are now 28 days from the day we changed the key. It takes 30 days to learn the key through this process. So right now, every validator out there that's looking at DNS Sec should actually trust both keys by now. If you don't trust both keys by now, you have a few days to make up for this, but you should be at the point where it's trusted in all these servers out there. So this comes to three questions that people may have to answer. One is, how do you know you're doing DNS Sec? There's a possibility that you may be doing DNS Sec and don't know it because of the way your system's set up. Two, how do you know you have the right keys configured? And 3 is, what do you do if you don't have the right keys configured? So again, I just want to emphasize that DNS Sec, this roll is going to be sooner than the RFC 5011 automated updates will allow us. So we have to update manually if we don't have it right now. So how can you tell if you validate? There is a test you can do. If you're familiar with DNS, you can launch a query for the dnssec-failed.org and ask for the A record. The A record is the IPv4 address. If you get back an answer that says serve fail, meaning that this is not going to, there's no answer here for you to get, that means you are doing DNSSEC, because DNSSEC has denied you seeing a badly signed answer. This record is actually poorly signed on purpose, so it will fail. If, however, and if you do this today and you see this, you know DNSSEC is being done by your server and it's using the current KSK. If you see the answer pop up in your window, that means you're not doing DNSSEC. It's getting through somehow. And yeah, if you're doing this, then you're not. You should see if you want DNSSEC to come on, but right now that's not going to be a problem for the rollover. If you have DNSSEC turned on, how do you tell what keys you trust? Now, it depends on what your software is. There are lots of software out there. There are a lot of versions of software out there, and there are a lot of different environments out there. So the answer is it depends. We have a website. We have a page being built right now, or actually it's been built, where someone has documented all of the ways you can check to see what keys a resolver has in it. It's being updated with more information as we go through here, but that URL is up there, and again, if you can copy this down fast enough, great. If not, I hope it's in the slides you download. It's an important reference. What you should see is indication that there are 2 keys trusted, the KSK 2017, the KSK 2010. And if you see this, then you're set. You're going to be fine when it comes time for rolling the key. To give a little bit more of a definitive picture of this, if you're running bind, you can run a certain command. This is good for just about all versions of bind, all the recent versions of bind, rather. Bind 9.9 is what I took this from. Bind 9.11 has a better command, which I'm not going to show. But this shows the 2 keys. An unbound, another very popular resolver out there, it has a way of managing the keys. If you look at the right file and you know where to look for it, you will see 2 entries in it for that showing the new key, the old key, and the word valid in brackets. That's important for this. So you see both of these, you're fine. If you don't see these, you have to fix something. And again, fixing this is going to be even more different stories here for me to tell. So we put it on a web page, another web page up there with another URL to go access. That should help you. You look down for the particular version of software you have. You may be able to know how it's put together and follow the instructions to update the trust anchors. Some more background information for this. The trust anchors are available in 2 ways from ICANN directly. One is through a URL, which is on top there. We also have the new trust anchors actually in the DNS already. The new key is actually appearing right now in the root zone. You can use these as sources for that information. And there are other ways to get this too, including software that's distributed. Software distributors include the keys. They have for years. And actually, this could actually be good and bad. It's good that all the new software distributions out there have the new key. The old software distributions have the old key, and they may need to be updated or may be using 5011 to learn the new ones and so on. But you want to make sure you have the right key nonetheless. Now, there are 2 kinds of issues we foresee with this, 2 possible issues. One is that we can have problem with fragmentation, and I will go into that in further slides. The answers from DNS Sec are going to get large for a period of time. The other set of problems are those related to just bad validation. If your name server is invalidating everything, then you have the wrong keys. Let me talk a little bit about fragmentation first, though. IPv6 fragments data differently from IPv4, and we've heard this before in this conference. This is not a good thing for DNS necessarily, because IPv6 says its protocol runs based on you send something really big into the network, it sends back it's too big. It tells you to try again with a smaller size. DNS has no memory. It doesn't know what it sent in the past, so when it gets back it was too big, you can't replay that response. So we're a little concerned about this. One of the concerns has been around this byte limit of 1,280 bytes, and to show you why we have some concern about this, 3 times in the next couple of weeks, we're going to exceed that limit for a couple of days. On this chart shows that from July 11th onward, we were at about 1,200 bytes, a little less than 1,200 bytes in our responses for the key set. Starting September 19th until the day of the signature changes, we will go up to 1414 bytes. We'll see what there's some concern about that, so we've addressed this, and so on. It'll go up and down through the next couple of weeks as we go through the roll. We've run some experiments about this, being concerned about it. We also noticed that a lot of TLDs have really large key sets. So we measured trying to get those key sets to see, do we really see issues coming along in this case? From that work, we have these recommendations. And these recommendations say, make sure your resolvers can do TCP. If you have TCP out there, it seems to get rid of all of these issues in getting the data. It's very important TCP's out there. The reason why we highlight this is for 2 reasons. One is historically, folks feel that DNS should not be on TCP. So we have to make sure that gets cleared out. And secondly, this is a permanent kind of change. Don't just changes for the key role, changes for DNS's health in general. DNS should have TCP support coming through to it. We also have a couple of test URLs listed here for seeing how big a response your resolvers can take or can receive from the internet. You might want to take use of that and make use of that to make sure that you have a clean network architecture. And again, these are permanent things. Look at this not just for the key role, but from here on out. So in the future, we still have to revoke the key. We have to revoke the old key at some point, meaning that what I said about RFC 5011 automated updates, it won't help you learn the key for next month, but it will help you down the road when we do some more cleaning up of the process. So we encourage the use of that if it fits your operational envelope. Also, there are undoubtedly going to be more roles in the future, and given the experience with 5011, we will repeat that as our basic way of doing work. So 5011 is actually something to continue having on your horizon, on your radar, even if it's not going to help you for the next 28 days. Change. And I'm finally going to list a few resources that ICANN has made available. I won't spend as much time going through them. One is a script that helps you pull down the trust anchor information from ICANN and show that it's been trusted and verified according to a couple of rules we have set out there. We have an automated updates test bed, which lets you see if your name servers will actually understand 5011. Again, that would help you in the future at this point, not so much for this key role. And we have documentation at a website, a web page hanging off of ICANN.org's main page. A little bit about the detail. This is the tool, some detail there. This is the test bed. It has a URL at the bottom for joining the test bed. And again, the main page we have. And then finally, these two are the URLs I presented in the presentation now that are new information. These have the how to tell what trust anchors you have and how would you fix that to make sure that you have the right ones. And so with that, I have the ICANN we like to engage slide. And I want to go back. The back arrow works. And I will leave this here for the moment so that those who want to copy that down, those are the URLs that are of interest for recent help that we're presenting. So with that, I'll turn it over to questions, or Jeff, or both, or what? What just go? Yeah. Okay.
Thanks, Ed, and good morning, everyone. I'm Jeff Houston. I'm with APNIC, and I'm waiting for slides. Slides are evidently up there. Yay! The real reason why I think we're all concerned is we're kind of worried if we're going to break things. And it would be nice to know in advance, how big the problem might be. So the problem is that if we get it wrong, resolvers that perform DNS Sec Validation that lose track of the trust anchor will fail to respond for everything. not just for sign names, but for all queries. Because they can't get the root in a manner that they need to trust because they're validating, they just don't answer anymore. And so resolvers that perform validation will go completely dark and fail to answer if they lose their relationship with the signed root. That's the kind of the scary downside of this, that if it goes wrong, those resolvers just basically turn off. So if we strip out sort of most of the hyperbole, the real question on the measurement side is, how big is this problem? And there's two questions. One is, what's the population of folk that sit behind resolvers that validate? What is the potential population that could be impacted? And let's go one further. Out of that group that could be impacted, what's the most likely scenario of real impact? What percentage of folk or what proportion of users might well be affected by this change as far as we can tell and measure? So the first kind of question to scope this is to understand how many users on the internet, out of these billions of users, how many users send their queries towards recursive resolvers that actually perform this validation? Because they're the people who might be sending their queries into something that won't answer if those resolvers don't track the key change. So that's the upper estimate. That's the upper estimate. And that leads to a kind of tricky question, because there is no doubt the DNS Sec, in fact the DNS is one of the most complicated parts of the internet. What you'd like to think is what's on this screen here. The DNS is insanely simple. The client has a question, it asks a resolver, the resolver goes and asks an authoritative name server, an answer comes back, happy client, everyone's happy. Yes? No. The DNS as it stands today is incredibly complicated. A lot of folk run server farms and load balancers. Google's public DNS service isn't a lowly machine answering 8.8.8.8. It's a large set of machines all over the planet with basically worker bees and robots doing the queries, and DNS intelligence is distributed through that. So you get these relatively complex scenarios, and when you ask, tell me the DNS resolvers that validate inside that mess, that's a really hard question to answer. And the other part of it is the protocol doesn't help. There's no chaining or visible trail in a DNS query. If Ed over here is a recursive resolver and I ask Ed a question, when Ed refers the question onward, as he should, there's no trace of me anymore. My identity doesn't exist. The first person or the resolver that gets that query only sees Ed. So each time you look at the DNS, you only ever see, if you will, the person who asked you the question, not the reason why the question was being asked, or the train of resolvers that asked it. So the best we can do is a cloud. The DNS is this fluffy cloud, and if you're a server, folk ask you questions. There are users out there, clients, who set those questions up, but how they got to the visible resolvers, nah, you really can't tell. So understanding that relationship between clients and resolvers that ask you questions is indeed tricky. And the result is that when someone says to me, Jeff, can you tell me the number of resolvers that validate? I have no idea. I can't even see them. I can only see a subset that ask authoritative name servers mine questions. That's not all the resolvers, that's a small subset. And the problem is that in various permutations of queries, turn off DNS Sec and ask the question again, which you can do, it's really not obvious and unambiguous which resolvers validate and which do not. So I can only talk about visible resolvers, and I can't tell if that visible resolver is actually validating or the thing behind it is validating, causing the visible resolver to mindlessly ask questions that look like it's validating. Confused yet? I know I am. The DNS is indeed a wondrous thing, and it works only by acts of deities. It's not deterministic. So resolvers, hard question. Users is what we can talk about. It's a lot easier to talk about the number of users who sit behind resolvers that validate. So measuring the DNS is tricky. We want to measure DNS Sec Validation. Now, again, it's really hard to instrument all the users all of the time. Can't do that. I instrument servers, and I use an ad network to set out questions that affect users ask their resolvers that ask our servers. And from that measurement, we can infer what's going on. Ed showed you a URL of deliberately badly signed DNS name. We use the same technique. Inside the ad we place, and we place around 10 to 15 million ads a day, so that's that many users all over the internet, they get 3 DNS questions that they need to solve. One that is well signed using RSA, DNS Sec, one where the signatures are deliberately tampered with so that it is signed but not validly signed, and one with no DNS Sec at all, which is our control. We get back 3 kinds of results. A user who sits exclusively behind validating resolvers will ask for both the DNS key and the DS resource records all of the time for both of those signed names consistently. And because one of them is unsigned, badly signed, the one that's badly signed will always have a serve fail answer. The user will never get the IP address. So we will see a fetch of the object that's validly signed and no fetch for the one that's badly signed. So those are the folk that validate. If you don't validate, I won't see any DNS key resource or DS key resource record fetches. You'll fetch both objects, but you won't ask for any DNS sec, so that's pretty clear. And as always on the internet, if there's a possibility it will happen, there's the third class of folk who kind of ask all the right questions but fetch both objects. The reason why is actually the engineering that happens inside many ISPs. One is never enough. And normally users are provisioned with the IP addresses of 2 resolvers. What happens if one validates and the other one doesn't? When you get back serve fail, the DNS signal for serve fail doesn't say, I tried to validate and it failed. What the DNS signal serve fail says is, I'm not going to answer you for unknown reasons. Now, being a persistent kind of client that you are, what are you going to do when you get back serve fail? You'll ask the other resolver, obviously. And if that one doesn't validate, that's when you get that third class of mixed signals. So the first lot, DNS Sec validating, and we can actually measure those people. How many users sit behind only DNS Sec validating resolvers? 12.45%. And we did, good God, 426 million separate experiments. So, you know, that's a fair amount, even out of 7 billion. And of those, 53 million exhibited exactly the behaviour we wanted. So that's a lot of DNS Sec validation out there. There's a huge amount. We can put it on a map, and you get some really surprising answers. Really surprising. Greenland, really surprising. Sweden, not so. Iceland, not so. And folk where you'd kind of think there should be a lot, not as much as you'd think. So it's all over the place. Why so much in Africa? Well, because one of the biggest public DNS resolvers out there is run by Google. Google's public DNS. Around 15 to 16% of the world's users send their queries to Google. And Google validates. And you go, well, why isn't the number 15%? Because a lot of folk have Google and another. And when Google says serve fail, they go, well, I'll ask the other resolver that doesn't validate. So that's why the number is lower than Google. You'll also notice that the world number dropped. There are a lot of people in India, and India used to be a different colour. When BSNL, their major backbone provider, which was running DNS Sec validation for that period, decided to turn it off. Sad face. And that caused a drop in the global numbers because there are a lot of users in that subcontinent, and sad to see, but you know that's why it happened. 12.45%, as I said. We can also take a stab at the other set, and it's 5.75% of the folk over and above that kind of have a bet each way. So in summarising, there is a lot of DNS Sec validation out there. The big picture, 20% of folk sit behind resolvers that know nothing about DNS Sec and show no evidence. Interestingly, 62% ask for the signature credentials. In DNS terms, they have the DNS Sec OK bit set. They get back the big answer, and then they decide to do nothing, which is actually the bind default behavior these days. If you do nothing with a bind release out of the box, it'll ask the right question, but never do the test. That's weird. You'd think if you're going to ask the question, you'd process the answer, but no. 6% validate and don't take no for an answer. I'll get the answer no matter what. And 12% are in the danger list of going, it's only DNS Sec. If DNS Sec doesn't work, we're toast. So that was the digression. Let me get back to this. Strip out the hyperbole. Can we estimate that extended population? Well, between 1 in 5 and 1 in 8 might be affected. But what's the likely impact? This is a tricky question because there's two problems going on with impact, as Ed has explained to you. The first one is you may not be running automated key management. Oops. So even though the right thing is happening, you've got a clause in your DNS resolver that says, leave it to me. But I resigned and caught the plane home because I was just a consultant. You're now running the DNS resolver and you have no idea what I've done, but when the key rolls, you're in deep, deep trouble. So we don't know how many folk are sitting inside that kind of space where they're not going to pick up the new root key because they haven't got automated key control. And the second thing, as Ed has explained, is the answers do get bigger, and for the DNS, that's not trouble-free. There are some issues with that. If you've got a managed key clause, you're just fine. If you haven't, you're not. But, okay, you just follow RFC 5011. This is the steps. It's in the slide pack. I won't go through it here. And the whole idea is if you look at the timetable coming up, the publish, withdraw and revoke stages are all sitting there. So the first concern, how many resolvers use manually managed keys? No idea. Cannot tell. There is a recent RFC out, 8145, that gets resolvers to tell authoritative name servers what key they're using. If you're tracking or following RFCs, you realise that RFC 8145 was published yesterday, really quite recent, and the code hasn't really hit a lot of places yet. So while it would be good, not useful for this particular key role, we're flying blind. So we cannot answer that, not yet. So we just can't tell. We will know. It will be obvious after October 11, once the caches expire, who's running manually managed keys, because they're going to go dark and not answer anymore. But beforehand, unfortunately not, can't measure that. The other one, though, we can measure, big responses, because big responses in the DNS come in various stages. This is the same information as Ed, using a slightly different presentation format, but as you see, 1,139 rising to 1,425. And we do know some resolvers really don't like that. The other thing is that there are 13 root server clusters and there are a minimum of 13 behaviours. For example, if you ask a.rootservers.net and it's trying to send you back one of these big answers, it won't, not in UDP. In V6, it will send you back a truncated answer, which will force you to run TCP in V6 to get the answer. B, C, D, they all behave differently. So there's not a single root server behaviour on large packets. There are basically 13 separate behaviours at least, and inside the Anycast families, for example, where Cloudflare is also serving FROOT as well as ISC, there are at least 2 different behaviours. The way Cloudflare works theirs and the way ISC work theirs. This is hard to measure. Because as a client, as a resolver out there, you've got 13 letters, 2 protocols, 4 and 6, and I'm not sure which one you will ask and what you will do if it fails, because that's your behaviour, and it's really hard to measure that out. So we've been unable to do a precise test. So, what we've found in looking at 1430 octet answers is that in doing that with a conventional behaviour, where we don't truncate, where we send back the biggest thing we can in UDP, we get a loss rate of significantly less than 1%. At that point, the noise in the measurement takes over. Is it 0.1%, 0.01%? I have no clue. The ad measurement system isn't that good. IPv6 only in UDP fragmentation is horrible. There are at least 40% of users that sit behind resolvers, including Google's public DNS, that if the only way to get the answer is v6 and you are fragmenting the UDP, you will not get the answer. If someone thinks they're going to run an all IPv6 network, including the DNS, and do that today, they have to figure out how they're going to address that problem. Because at this point, that says you can't do this. That's just an unbelievably high loss rate. So what saves us today and what makes this rollover work today? v4 is around. And because v4 is around and there are no v6 only resolvers as far as I can see, no one's in that bucket. If they don't get an answer, they'll try v4, it will just work. And more to the point, there are some folk, I don't know whether it's deliberate or not, who have been testing this out for years, because .org domain has a DNS key response of 1,650 octets, and I have yet to meet anyone or hear of anyone complaining that .org is not a domain that exists when you do validation. So apocryphally, the data point says, look, if there is a loss, it's really low. Our experiments say it's well under 1%. So we don't expect this to be a major factor. Difficult to quantify, but we think it's basically down around much lower than 1 in 100. So not a big issue as far as we can measure. So the summary of this, some resolvers will fail, absolutely. The ones who are on manual key management who don't pick it up, no go. We suspect there might be some corner cases who can't receive large DNS responses. Suspect. Not one of the mainstream ones, it's not one of the 2,000 or so that do most of the recursive resolver work, but it's likely, as I said, it's the internet, everything that could happen will happen. The other thing to note is October the 11th is not the day when it breaks. That's the day when it might break because your local cache has to expire and you have to ask again. At the time you ask after your cache has expired is when you go dark. Because if you haven't got the right key, that's when you fail. So failures will start at around October 11 if there are, and will continue for a day or two. What will users do? What they always do, go and find something that works and switch over. I'm not sure anyone will be stranded. I'm really not sure. We will find out, we will be looking. But that pool of users that will be affected with no DNS, I suspect it'll be really, really small, but we will see. What can you do? Not Jeff, what can you do? Wrong slide. What can you do? If you run a recursive resolver, you really, 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 really should check that you're doing automated key management. If you're not, as Ed said, it's too late to turn it on now. Manually install the new key because that's the only way you're going to pick it up because the 30 days is over. So check your resolver config. If it's old, install the new key manually. And you should check your key set anyway. The index number was 20326. Something like that. There's no need to turn off DNS Sec Validation. I'm like, this stuff is easy. It's not that dangerous. It'll work. Just keep your eyes open. So with that, I think Ed and I can collectively take questions. It's all Ed's fault because he's with ICANN. I just do the measurement. So questions?
This is Gaurav. That is the correct affiliation for the things I'm going to talk about. First for Ed, whatever they do on the political side of ICANN, I stay far away from that, but on the technical side, they do a good job. As one of the root TCRs. I kind of affirm that the theater around the signing is really detailed and there's nothing wrong with it. As one of the things we do as TCRs is to publicly affirm that they don't mess up so badly or haven't messed up. So thank you for that work that is done with the key signing ceremonies. I'll be soon publishing some stuff about it. But question for Jeff. Do you think DNS is still relevant when people are using more and more apps? And why would we run a recursive DNS server? You know, it's all in the apps now.
Names are even more important because apps are name-based. They're not hardwired with addresses. In these days of clouds and data centers and so on, addresses are incredibly malleable even for servers. And almost one of the only places where you see an IP address hammered hard into folks' brains is 8.8.8.8. What's the equivalent address of the v6 side of Google? Nobody knows. Names are important. Names will remain important. Names are central to this work. And indeed, someone once said, if you could actually look and see what questions are being asked in the DNS, you don't need to run a search engine to find out what people are doing. The DNS will tell you everything. So no, the DNS is central to all of this, and if the DNS doesn't work, you haven't got a network. Apps notwithstanding, DNS is central. So this is important stuff. But at the same time, you know, I feel confident as a user of this system that the engineering of the key change is responsible, that we are not heading headlong into disaster, that quite frankly there is an astonishing amount of resiliency and backup in this system, and that I don't see that this is going to be a significant issue, right? One or two folk might be black for an hour or two as operators scrabble a bit with their manually managed keys, but this time around, that's all I expect. What will be interesting, and what will be incredibly interesting, is if we get to an all v6 DNS and we roll keys, that's when you're going to find a little bit more of a problem with the fragmentation issues in v6 only. We appear to be some years away from that, no matter which way you cut it. That's not a here and now problem, but we should bear it in mind.
Thank you. Thank you both, Jeff and Ed, for those presentations. If you'd like to learn more about the key role, please, the slides again will be up on the website, the APNIC44 website. ICANN has a very detailed key KSK rollover page, as does APNIC. So if you're looking for more information on this, there's a wealth of information out there. Please do look at that and make sure you're ready. Thank you very much. Lunch is now ready. If you're there's